Hi, this is Nathan Tintle. In this Learning Goal video, we're going to discuss how to interpret summary statistics on a data set. We will use the Geyser Eruptions dataset to talk about this learning goal. In particular, we're going to talk about the mean, the median, and the new ideas of quartiles and interquartile range. Let's start by talking about some basic summary information on the two parallel dot plots of interruption times for Old Faithful. When we look at dot plots of a quantitative variable like we have here, we talk about shape, center, and variability. The shape of these distributions for 2003 is fairly symmetric. There are a couple of extreme values, maybe outliers down around 50 to 60 minutes, but for the most part the data is pretty symmetric near 90. In 1978, however, we see what's called a bimodal distribution, meaning we have two clusters of data. We have a longer interruption time cluster and a shorter interruption time cluster. When we talk about center, we can talk about both the mean and the median, and we can compute those for both 2003 and 1978. And one of the goals of this analysis is to compare how the interruption times are different between the 2 years. And so we can see in 2003, the average interruption time is quite a bit larger, as is the median, compared to 1978. Finally, we can talk about spread. The spread in 1978 is quite a bit larger. We have those two clusters there. So the standard deviation is 13 in 1978 compared to only 8.5 in 2003. In other Learning Goal videos, we've talked about the fact that the mean is impacted by extreme values and skewness. It's going to get pulled in the direction of the extreme values or the skewness, whereas the median is less impacted. Now, we also talked about how the standard deviation is impacted by extreme values and skewness. But until now, we have not given you another option to talk about variability. We'll talk about one of those options now, introducing the ideas of quartiles and interquartile range, which is abbreviated IQR. To understand these ideas, remember that the median is the number so that 50% of the data is bigger and 50% of the data is smaller, right? It's the middle number. This means that the median can be thought of as something called the 50th percentile. A percentile is a number so that that percent of the numbers are smaller. So if the median is the 50th percentile, then 50% of the data values are less than that number. So if we say the median interruption time in 2003 was 91, 50% of interruption times were longer than 91 minutes and 50% were shorter. Let's translate that idea to other percentiles. So the first quartile is the 25th percentile. This means 25% of the numbers are smaller, 75% of the numbers are larger. Another way to think about it is it's the median of the numbers less than the median, right? Because we're splitting the numbers less than the median in half. The first quartile for 2003 was 87. This means 25% of interruption times in 2003 were less than 87, and 75% were more than 87. We can also compute the third quartile. The third quartile is the 75th percentile. The third quartile in 2003 was 98. That means that 75% of the interruption times in 2003 were less than 98. When you compute the third and the first quartile, you can compute something called the IQR. The IQR is the middle 50% of the data. It's the third quartile minus the first quartile. And it's a measure of variability of a quantitative variable that is more robust to skewness and outliers than the standard deviation is. In 2003, the interquartile range is 11 because we take the third quartile, 98, and subtract the first quartile, 87. In 1978, the IQR is 23, quite a bit larger, reflecting the much larger variability in interruption times in 1978. This gets us to the last idea in this video, and that's the idea of the 5-number summary. The 5-number summary is a set of 5 numbers that some people use to summarize a quantitative variable. They tell you the minimum value, that's the smallest value in the data set, the first quartile, the median, the third quartile, and then the maximum, the biggest data value in the set. A couple of words of caution. The IQR is not used as commonly as the standard deviation. In part, this is because theory-based approaches are not available as readily for the IQR and the median. And finally, in that 5-number summary, when you report the minimum and the maximum, realize that those are very affected by extreme values. So some people actually say the minimum and the maximum that are not extreme outliers. So what's the smallest data value that's not an extreme outlier? The biggest data value that's not an extreme outlier?